This is Neha Chauhan here. I'm a teacher expert at Cuemath with a teaching experience of more than 3 years. Subjects which I primarily teach are mathematics and reasoning, and the regions that I cater to are India and US. Now, as today's topic is a fun-filled topic, which is coding and decoding, so we'll be doing a lot of interesting questions because it's coding and decoding. So I request you all to grab a notebook and a pen so that you can answer the questions along with me. Also can take down important tricks and tips of how to solve these questions, which are based on different sorts of coding and decoding. So the first thing that we start with is the table of contents so that we know what all are we going to cover in today's masterclass. We are going to understand the core concept of what coding and decoding is. Then we'll see some objectives based on which we'll be solving problems, which would be of basic level as well as advanced level. And then we'll see what are the takeaways, what are the learning outcomes that we have from today's masterclass. Okay, so before we start with our today's masterclass, that is, before we dive into the core concept of coding and decoding, here's a quick test. It's like a pre-test to see whether you do have that knack of solving these type of problems or not. And if not, then definitely we'll be going to cover that up in today's masterclass. So the question here is, it says that if a desk is called chair, chair is called blackboard, blackboard is called duster, duster is called chalk, then where do you sit in the classroom? So you all can try to answer this question and put your answers in the comment sections. Meanwhile, for those of you who do not know how to go about this question, I'll be solving it up for you. So the best way of solving these type of problems is that you write the code and the decode words. So I'll just write here the code and the decoded word. Okay, so the first thing that we see, it says if desk is called chair. So basically desk has been coded as chair. So the code is chair, for which the actual meaning is desk. So we write this up here. Then it says chair is called blackboard. So basically the code for chair is blackboard. So we can write here BB standing for blackboard, and the actual meaning of blackboard is chair. Now then blackboard is called duster. So the code for blackboard is duster. So I would write here duster, and the actual meaning of, or the decoded meaning of duster is basically blackboard. And then duster is called chalk. So the code for duster is chalk. So I write it up here chalk, and this is actually duster. So you always have to answer your questions looking at the decoded words. So basically when they ask you where do you sit in the classroom? So where do we sit in the classroom? We sit on the chair. So this is the chair. But how that chair has been coded? The code for chair is not chair itself, but the word blackboard. So the answer to this question would be blackboard. That is, we sit in a blackboard because the code for chair is blackboard. So whenever you are saying blackboard, it doesn't really mean blackboard, but it means chair as per this question. So this is how you solve these type of problems. And I know you all would be finding it really interesting because this is something which is different than we do, the other regular maths. So with this, we'll be moving on to our next part, which is what is coding and decoding. So you've already seen one example of coding and decoding. So what did that mean? So basically, whenever you are trying to convey something without actually revealing the core context of it, and you only want the core context of that to be known by selective people who know the decode of it, is called as coding. So the primary objective of coding is that you are trying to convey or transfer information from one place to another place, or from one person to another person, without anybody else knowing about it. Because the way you have coded it is only with you or with the person with whom you are trying to share it. Nobody else would know how you have coded that. So whenever I would be saying blackboard, people who do not know that blackboard is the actual code word for chair would think that I'm talking about blackboard. But that's not true. Whenever I say blackboard, it actually means a chair as per the codes we have done. So if I would say blackboard, and if you know that the meaning of blackboard is basically chair, You're processing that in your head, in your mind, that blackboard whenever is uttered out, it's basically meant or is meaning chair. So deciphering the meaning, the actual meaning of the code is called as decoding. So what I am doing is coding, and what you are trying to fetch from that code, which is the actual information, is called as decoding. So I hope you all have understood the basic code concept of what exactly coding and decoding is and why do we do it. Let's see the definition. So it says coding is a process used to encrypt a word. By encrypting, we mean that we're trying to give it a new layering so that the actual word is hidden and it's not revealed to anybody else. So it says coding is a process used to encrypt a word, a number in a particular code or pattern based on some set of rules, which you yourself can define. It is absolutely on you of how you want to code a word or how you want to code a number. So, but there has to be a rule to that. You should know that rule. And decoding is the process to decrypt. That is, by decrypting, we mean that you get back the original information from that. You decode it, the pattern into its original form from the given codes and the rules that you know. So that is called as decoding. Now that we've understood, we'll see what the objectives are. So the different types of coding that we will be learning in today's master class is letter coding, number and symbol coding, and then substitution coding. So what are the applications of coding and decoding? So one major application I've already given you for coding and decoding is that you do not want to reveal the information that you're transferring from one place to another or from one person to another person to anybody else. We don't want it to be broadcasted to everyone. We don't want everyone in the world to know it. We just want only a specific set of people to know about that particular information. Now, this comes really very useful, in a lot of places where you want to keep a secret, like, in defenses, like armed forces, Army, Navy, Air Force. They do use these words so that the enemies do not know what we are trying to convey or what our information is. So that is one. The agencies, the investigating agencies that we have, they also do the coding and decoding so that whenever they're trying to speak to somebody or whenever they're passing one information from one place to another place, it doesn't get delivered to any unwanted person whom you do not want to convey that information to, should not get leaked. And that's why we code it. Let's see some more applications here. So encryption and decryption, which is what I told you just now. Communication, we also do communication as like this is too much of information for you all children who are in lower grades, but whatever communication happens over telephone, mobile phones, doesn't really happen actually the way we speak. Whatever we speak gets coded in certain form, and then the person who is receiving whatever we're saying, in the mobile phone, it gets decoded. So in communication, in language, and in programming, there's so many places where the applications of coding and decoding can be seen. But I've given you one code concept so that you can understand where exactly and majorly coding and decoding is applied. So we here start with the first one, which is letter coding. It says, the question says, detect the coding pattern or rule and answer the question below. If brown is written as ZPMUL, then violet is coded as what? So there is a certain rule which has gone behind coding brown as ZPMUL. We have to first understand and detect the rule which is applied here, and then we need to apply the same rule on violet to code it. Now let's see what the options are. Okay, so these are all the options which we have. Now, the best way of solving these type of coding questions wherein letters are involved, it's best to have the alphabetical series right in front of you. So we'll get the alphabetical series here. All right. So I'll just write it up on the board that how is brown coded. So brown has been coded as Z, P, M, U, L. So let's locate where B is. This is B. And where is Z? You go back, there is A. If you would go back, round the way back to Z, here is Z. So what have we done? We have skipped one letter backwards to get from B to Z. This is one way of understanding it. Now let's see if the same thing has been applied to R or not. Where is R? Here is R, and R has been coded as P. Where is P? We go backward, we skip Q, and we arrive at P. So again, the same thing has happened. We have skipped one letter backward to code for R. So that becomes P. The code for R is P. Now O has been coded as M. Our O is here, and M has been obtained by skipping one letter backward again. Then the same thing should be happening with W. W is here. We skip one letter backward. We are skipping V and we are going to U. So that's how W has been coded as U. And N has, the letter N has been coded as L. So let me just do it with a different color so that you clearly understand it. N is here. You skip one letter backward. Skipping M, we arrive or land at L. So the rule which we have understood here to code any word is that you skip one letter backward to code that particular alphabet. So I'll clear this off and we'll try coding the word violet. So we'll write it up here, violet. Now we have to keep on skipping one letter backward in order to code all of these letters in the word violet. So the first thing that we have is V. Where is V? Here is our V. You skip one letter backward. So you skip U and you arrive at T. So V has been coded as T. Then I is here. We skip H and go backward. So we get G. So I has been coded as G. Then O is here. Skip N and land at M. L. So skip K and land at J. E. Skip D and land at C. Okay. And then comes T, which is here. Skip S and land at R. So this is the code that we have obtained for violet, which is T, G, M, J, C, R. So if you would look at the options which are given, the correct answer to our question becomes option A, which is the same as T, G, M, J, C, R. And this is how we solve this problem of letter coding. I hope you all understood it. And the best way of doing any letter coding or decoding is to have the alphabetical series right in front of you. If you do not have that, you can just quickly scribble it up in your piece of paper and then try decoding the pattern or the rule on which the coding has been done. And then the same thing can be applied to the word which has been asked to be coded. With this, hoping that all of you have understood this question. If not, you can always post your doubts in the comment section. We'll be moving on to the next question, which is based on number and symbol coding. So it says again, to detect the coding pattern or rule and answer the questions below. It says if chair is written as 1, 2, 3, 4, 5, that is chair has been coded as 1, 2, 3, 4, 5, and rent is written or coded as 5, 6, 7, 8, then the word rare is written as dash. Basically, given the two words chair and rent and the way they have been coded, we need to detect or understand the pattern on which they have been coded, and then we have to apply the same coding rule on the word rare to find its code. Now let's see the options. These are all the options that we have. Now what I'll do is I'll write both of the words which are given in the question, which is chair, C, H, A, I, R. C has been coded as 1, H has been coded as 2, A has been coded as 3, I has been coded as 4, and R has been coded as 5. The next word which is given is rent. So the word rent has been coded as 5, 6, 7, 8. So R is 5, E is 6, N is 7, and T is 8. Now something which we see common is the letter R, which has been coded the same in both the words. So that means each letter has got its specific number code, and we have to go by that. So that would mean that C, the code for C, the letter C is 1, H is 2, A is 3, I is 4, R is 5, E is 6, N is 7, and T is 8. Now the word that we need to code is rare. So we would write that up here. And we would look for the letter code from the two words which are already given, the number code for these letters. So clearly R has got a code number of 5, so we would write 5 here. A has been coded as 3, so we write 3. R is again 5, and E has been coded as 6. So the word rare can then be written here. I can write it below this 5, 3, 5, 6. Now, if we would look at the 4 options given in this question, the correct answer to this question becomes option B, which is the same as 5, 3, 5, 6. So I hope you've understood how to do the question, which is based on number symbol coding. That is, a letter has been assigned with a particular number, and that's the way it has been coded. And how could we get to that is because what we saw is that R was coded the same way in both the words. The letter R was coded the same in both the words. So that means that each letter has been assigned with a specific number. And that number is the code for that letter. Hoping that you've understood this question, we'll move on to the next question, which is again of the same type, number symbol coding. Here we also see some symbols. So if neck is written as 1 to 3%, luck is written as plus at 3%, and like is written as plus division percentage 2, then nice is written as what? So we'll look at the options here. These are all the options that we have. Again, the exact same thing we're going to do. We would write the word neck and see how neck has been coded. So we'll write the codes of it in front of it. N has got the code 1, E has got the code 2, 3%. Now let's go on to the next word which is given in the question, which is luck. L-U-C-K, and we'll see how each of these alphabets have been coded. L has been coded as plus, U has been coded as at, and then C has been coded as 3, K has been coded as percentage. We go on to the next word, which is like, L-I-K-E. The code for each of these alphabets is L is plus, I is division, K is percentage, and E is 2. Now what you would look at is that K has been coded the same way in all the 3 words, which is a percentage. And any other common thing that we see here is any alphabet which has been coded the same way is E. E has been coded as 2 here as well as here. Both places E has been coded as 2. Then if we were to look at what we would see is that L has been coded as plus here as well as here. So that means each alphabet has been given one specific symbol or a number as its code. So then we can look from these alphabets in these 3 different words and arrive at our codes for the word nice. So I'll write up the word nice here, N-I-C-E, and we'll be writing the codes for it. N, if we would see from the first word, has been coded as 1. I from the third word, like this one, has been coded as division. C in both of these words here has been coded as 3, and E has been coded as 2. So the code for nice can be written as 1 division 3 2, which is same as option B, and that is the correct answer to our question. With this, we move on to our next question, which is substitution coding. We had already seen a type of it at the beginning of the masterclass, wherein we had a quick test. So I've already told you the methodology of how to go about these type of questions, so you can quickly try answering this. Meanwhile, for those of you who could not understand it, we'll again go by the same method. It says here, if dog is called cat, cat is called lion, lion is called rat, then which of these lives in a forest? So these are all the options. The best way of doing it is you write the code and decode. So I'll write the code and the decoded word here. Okay, so okay, dog is called cat. So the code for dog is cat. That would mean cat is the code word for dog. Next says cat is called lion. That is the code word for cat is lion. That means lion is the code word for cat. Then we have lion is called rat. The code for lion is rat. So I write here rat, which is the code word for lion. So that's it. That's all that we had in the question. Now the question is, which of these lives in a forest? So as I had also told you at the start of the masterclass when we were doing the quick test, that you always go by the decoded words, the original words. Now who lives in a forest out of dog, cat and lion? A lion lives in a forest, but lion has been coded as rat. So if you want to specify the animal who lives in forest, you would have to make use of its code word, and the code word for lion is rat, and hence the correct answer to this question is option A. With this, moving on to our next question. Okay, so again we have the same type. Quickly, all of you can read this question, try answering this question. Meanwhile, I'll be solving it for all of you, and you can then check whether you've gotten to the right answer or not. If cake is called egg, egg is called coffee, coffee is called tea, then which is white in color? These are all the options that we have. So not necessarily always you have to write the code first and the decode. You can write the decode, that is the actual word, and then the code for it. But all you have to keep in mind is to always go by the decoded words, the actual words. So cake is called egg. So cake has been coded as egg. I write egg. Then egg is called coffee. So I write egg has been coded as coffee. Then we have coffee, which has been coded as tea. Now the question says, which of these is white in color? So out of the original words which we have, which is cake, egg and coffee, which is white, we clearly know that egg is white in color, but egg has been coded as coffee. So the correct answer to this question would be coffee, because whenever you are saying coffee, it is not actually coffee, but it means egg, which is white in color. And that's how you solve these type of problems, substitution coding. We'd move on to the next question then. Okay, another question which is based on substitution coding, but it also involves months here. So you should know the concept of the calendar, how to read a calendar, know your months, how many days are there in each month, all of that you should know. So it says here, if January is called March, March is called April, and April is called May, then which of the following month will have only 30 days? These are all the options that we have. We go with the same concept of writing the decodes and codes. So the decode months and the coded months go in here. We would write one below the other. January has been coded as March. So the code for January is March. March has been coded as April. So March has been coded as April. We write here April. And then April has been coded as May. And it says which of the following month will have only 30 days. So again, you would go only by the original words, the decode words, which is January, March, and April. Out of January, March, and April, we know that January and March have 31 days in them. The only month which has 30 days in it is the April, which has got 30 days. But April has been coded as May. So the answer to this question is option D, which is May, because the code for April is May, and April is the month wherein you have 30 days instead of 31 days. So the answer to this question becomes May. Moving on. So here we come to the question which is an advanced level question, and again it's a type of substitution coding. But one more concept which is involved here is the concept of symmetry, lines of symmetry. So before we get into this question, I'll quickly just tell you what line of symmetry means. If you had any shape, be it a two-dimensional shape or be it a three-dimensional shape, which is basically a plane shape or a solid shape. If you draw a line to the given shape which divides the shape into two equal halves which are replicas of each other, so that when you try to superimpose, or that is when you try to overlap one half onto the other, it exactly matches. It's not more, it's not less. So I would reiterate my definition for the line of symmetry. A line which is drawn to either a solid shape or a plane shape, which divides the shape into two equal halves. Halves which are the replicas. Replicas in the sense they are the ditto same of each other. And when you would try to overlap one over the other, they would exactly match, not being more, not being less. Such a line is called as line of symmetry. Now let's get into this question, which says that a triangle means a square, square means a circle, circle means a rectangle, and a rectangle means a cylinder, then which has exactly infinite lines of symmetry. So we'd go with the same concept of code and decode. But here in this question, the code has been given. Like, what does the code actually mean? So we'll be writing the code first and their decodes. That is the actual meaning of it. So the first it says is a triangle means a square. So whenever you're saying triangle, it actually means a square. A square means a circle. A circle means a rectangle, and a rectangle means a cylinder. So as I have always told you that you go with the actual words and not the codes to answer your question. So we have to choose amongst a square, a circle, a rectangle, and a cylinder which has got infinitely lines of symmetry. So if we would see that a square has 1, 2, 3 kind of symmetries, like it has got only a specific number of symmetries, these many. So 1, 2, 3, 4, and 5. A rectangle would not have so many, because if you would try to overlap these two, they would not be exactly the same. So it has only 1, 2, these two are the lines of symmetry for a rectangle. And then we come to the part which is the cylinder. Now cylinder is a solid shape. So this will not have a lot of lines of symmetry. It will have only a specific number again, because if I draw it anywhere, like a slant line like this, a slant line like this, then these are not the lines of symmetry, because on these lines, if you would try to fold the shape, it will not be exactly overlapping the other one. So the only one which has got infinitely many lines of symmetry is a circle. So if you have a circle, you draw like line like this passing through the center, it will have two halves which are replicas of each other. If you draw a line passing through center like this also would divide into replicas of each other, two halves. This and this, like so many you can draw. So a circle has got infinite lines of symmetry, but a circle has been coded as a square. So the correct answer to this question becomes option A, which is a square, because a circle has infinitely many lines of symmetry, but a circle has been coded as a square here. So the correct answer to this question becomes option A. Moving on to our next question, which is, okay, so this is again, this is where we see balance 1 and balance 2. It says how many squares should be placed on the right side of balance 2 in order to make it balanced. Okay, so this is the question mark which we need to fill in. Now a balance is, always balanced. It's, in equilibrium. It's staying constant like this, parallel to the ground, whenever the weights on both sides are equal. So we'll have to understand from balance 1, how does it go? So what we see is 1, 2, 3. 3 squares and a triangle balance out 1 triangle and a circle. So what is common to both sides is 1 triangle, which can be cancelled out. So what we get to understand is that 3 squares put together are equivalent in weight to 1 circle. That is, 3 squares can balance 1 circle. So here, instead of a circle, we can have 1, 2, 3 squares. So 1, 2, 3, 4, 5. Now to balance 5 squares, you must have 5 squares here as well, so that the balance is parallel to the ground and is not moving up or down. So the correct answer to this question would be 5. And let's see if we do have that in the options here. So the options that we had were 4, 8, 6 and 5, and yes, the correct answer to this question is option D, which is 5. With this, we come to the learning outcomes of what all we learned in today's class. We learned comparing numbers or letters with a given code, and applying the same set of pattern or rules to find to solve to exactly get the logic and then solve the problem. Whether you've been given with a word or you've been given with certain numbers and you were asked to code them, you just have to detect the coding rule, coding pattern, and apply the same. We learned how to work on substitution coding problems. You have to write the codes and decodes. Always go with the decodes, that is the original words, and try solving it. So these are the different ways possible in which you can code and decode certain information, a certain word or numbers, and understand how you can apply rules over different sort of words to get the code in the same way. So basically we learned 3 types of coding today: number letter coding, symbol coding, and substitution coding. So letter, number, symbol, substitution, or be it all, you know how to solve it, you know how to go about it from today's masterclass. So with this, it's a wrap for today's masterclass. For all the parents and teachers who want to get their child registered for TUCO 2020, the registrations are already open. The information that you need, all the information that you need regarding the registration would be given after this masterclass. So stay tuned and look out for all the information that you need. It'll be given in detail, so that you can register your child or your student for TUCO 2020, which is the ultimate Cuemath Olympiad. So as we all saw in today's masterclass, how logical reasoning inculcates the ability to think logically in a child, they start thinking in an innovative manner. They also strive to get to the answer in the shortest possible way. And this is exactly how a student gets trained by a Cuemath expert, and all of it is being provided in Olympiad masterclasses by Cuemath. So with this, I would like to introduce the TUCO registration forms. Every student who wishes to take up the real-time Olympiad examination by Cuemath, please go ahead and click on the link given in the description box below. The registration amount for TUCO is Rs 200 only, and the benefits that you get on registering for TUCO is that you get a complete course curriculum to prepare for it, which is worth Rs 5,000. So every time we have a masterclass, an Olympiad masterclass as we had today, which is scheduled, you can join us there and then later can work on extensive sheets on the same topic through the course curriculum provided when you register for TUCO. So make sure you do not delay and register yourself to get the most out of the curriculum worth Rs 5,000 just for Rs 200. And with this, we'll be winding up today's